Hello, it's Shrieker. Welcome back to Montville Math, and today we'll do a fairly difficult topic, multiplication and division of polynomials. If you know it's not difficult, it's just tedious, which means it's takes a long time and slightly boring, but okay. So x squared plus 2x plus 5 times x plus 3. Okay, so let's just start multiplying. Okay, so I should tell you my trick for multiplying polynomials. Is not really a trick because it's the easiest way to multiply polynomials. Is first multiply the first number by the first number by the second number. Then the second number by the first number and the second number by the second number. And the third number by the first number and the third number by the second number. Okay, so x squared times x, just x cubed because x, yeah. And then x squared times 3 is 3x squared. And then 2x times x is 2x squared. So we can, 3x squared plus 2x squared is 5x squared. Okay. Then 2x squared times 3 is 6x. And 5 times x is 5x. So 6x times 5x. You can cross that out and say plus 11x, right? So that's all good. And then 5 times 3 is 15. So we successfully multiplied our polynomial to get x cubed plus 5x squared plus 11x plus 15. Perfect. So let's take a simple problem. I want to do something that slightly relates to a simple problem. Okay. So 3 times 2 is 6, right? I mean, yeah, of course. And 6 divided by 2 is 3. So I want to see, now that we have our polynomial, if we divide this by x plus 3, we get x squared plus 2x plus 5. Wait, how are we going to divide it? Oh, I know how. Okay, so a polynomial, so x cubed plus x cubed plus 5x squared plus 11x plus 15 divided by x plus 3. Okay. So how are we going to approach this? Slightly stuck. Give me a... Oh! I have an idea. If you multiply x by x, if you multiply x plus 3 by x squared, it won't really match with the 5x squared, but we can cancel the x cubed. I'll show you what I mean. So you multiplied it by x squared. We're treating it like a regular division problem. Like whenever you divide 6 divided by 2, I don't know, you do 6 divided by 2, 2 times 3, and 2 times 3 is 6, and then you subtract and you get whatever you have left and you're done. And with 2-digit or 3-digit or 4-digit numbers, you just repeat the process of subtracting and continuing. We're going to do the exact same thing here. It's actually pretty easy. Watch. So x plus 3 times x squared. So x plus 3, x times x squared is x cubed. 3 times x squared is 3x squared. Okay, so subtract this and move on. 2x squared because we're subtracting a positive, and 5 minus 3x squared is 2x squared, plus 11x. Okay, so x plus 3. So what do you multiply by x to get 2x squared? You multiply by 2x, right? Okay, so when you multiply x plus 3 by 2x, you get 2x squared plus 6x, right? 6x, okay. So now so 2x squared plus 11x minus 2x squared plus 6x. I'll redraw that. Sorry if it doesn't look that neat. So 2x squared plus 6x. Okay. Okay. So now you subtract that, you get 5x plus 15. 5x plus 15. So what times x plus 3 is 5? Well, what times x would equal 5x? 5 obviously, right? So you get 5x plus 15, and 3 times 5 is 15, x times 5 is 5, and you end up with a remainder of 0, which means that this is our final polynomial, and we are all happy, and we're almost done with the episode. We're not done yet. Okay, so it works. When you divide when you divide a polynomial by another polynomial, then if you x times y equals z, then z divided by y equals x. Exactly what we proved here. Works for everything from numbers to polynomials, which is good for us. Okay. So what if we did something a little different? Okay. So you might be saying, what'll happen if there's a remainder and it's not a nice sweet 0? We have options for that too. We have options. Okay. Let's divide x plus, let's see, x plus 4 by x. Give me a second. Sorry. Okay, so let's divide x plus 4 by x cubed plus 5x squared plus 11x plus 15. Doesn't look like it's, I have a feeling it's not going to be a nice happy remainder. Okay, so x plus 4 into x cubed plus 5x. Let's do exactly what we did. Put an x squared because x times x squared is x cubed. You just need to make sure it fits in the leading coefficient. The leading coefficient of this fits in the leading coefficient of this, what you multiply to get into that. Okay, so when you multiply, so you get x cubed. It doesn't look like a 3x cubed plus 4x squared. Subtract both the whole thing, and you get x squared plus 11x. So you multiply by x, and you get x squared plus 4x. Okay. So now that you have x squared plus 4x, you subtract that and you get 5x. Wait, 11 minus 4, what am I doing? Not 5, 7. Okay. 7x plus 15. Okay, so you add 7, because 7 times x is 7x, plus 28, subtract, and you end up with negative 13. And that is not a happy 0. However, we're not done. We can finish the problem. Okay, so all you have to do is r negative 13. No, that's not how you say remainders in polynomials, in dividing polynomials. Instead, what you do, like, let's take an easier problem, 28 divided by 3, so 3 times 9 is 27, and 8 minus 7 is 1, so it's just 9 and 1 over 3, right? Remember when we used to do easy problems like that? Well, that same concept is going to really come in handy, because it just, the remainder divided by the divisor. Okay, so you just minus 13 over x plus 4, and we are all done. Whew. That was fun, right? Or at least not as completely boring as you thought it would be, okay? Thank you for watching this video of Montville Math. Be sure to like, comment, and subscribe. Have a good day.